Welcome to Sketchy. We take all the super complex stuff you need to learn and turn them into memorable visual stories packed full of everything you need to know on test day. Click the link in the corner or description to try for free for 7 days. Now let's get to it.
Ahoy, mateys! It's time to talk about the Chlamydia species. And we're going to be talking about some pirates and their pirate ship. And it's a pretty good association too, because if any group in history had rampant STIs, it was the pirates. And this video on chlamydia is called The Pirates of Clam Island. So there's a lot of information to learn about chlamydia, but we ambitiously thought we could tie it all into one story. But we'll still break it up and make it as simple as possible. So first we'll discuss the general characteristics, the life cycle, and identification. Then we'll move into several clinical presentations, and then finally finish with treatment. So let's get started. Here we have a small island with a pirate ship that is run aground. First, let's go over some of the microbial characteristics. It's important to remember that Chlamydia species is an obligate intracellular bacteria. In past drawings, we've associated being an obligate intracellular organism with an indoor scene. However, this would be kind of hard with the pirate ship. So we've demonstrated it slightly differently. We have this ship running aground, and it's stuck on an island. This round, white, sandy island represents the cell, and the ship is the bacteria that's stuck on the island. So that's obligate intracellular. The white island also signifies the lack of staining with a gram stain. This is very much similar to the Rickettsia species, who are also obligate intracellular and demonstrate poor gram staining. And additionally, just like the Rickettsia species, the reason why chlamydia is an obligate intracellular organism is because it can't create its own ATP. With all that's going to be discussed, there's no symbolism to depict that fact, but it should be pretty well ingrained following the Rickettsia videos. Another interesting aspect about the cell wall of chlamydia that's frequently tested is the lack of muramic acid, which is a component of peptidoglycans that make up the cell wall. And we'll demonstrate this with the banner that hangs on the side of the ship. Muramic sounds like mermaid, which we thought would be a good way to remember this fact. So we'll have a sign that demonstrates that there are no mermaids or no muramic acids on board. The lack of muramic acid in the cell wall becomes important in terms of treatment options, which we'll discuss later. Okay, let's move on to the life cycle. And this will be demonstrated by these pearls and clams. Essentially, there are two forms of the bacteria in its life cycle: elementary bodies and reticulate bodies. The beginning of the cycle is simple. We have the bacteria, which is the pearl, sitting outside of the cell, or the clam. What form is the pearl in now? Well, this is the first stage of the life cycle, so it's the elementary stage. Simple, right? Okay, now stage 2 is after the bacteria is inside the cell, or inside the clam, and as you can see, the clam is split into two, so we can see inside and that there are two pearls. And this form is called the reticular body, and it's how the bacteria multiply, through binary fission. The reticular body is known as the active form that can multiply, something that the elementary body can't do.